Hello my dear viewers, welcome to today's lesson. We are going to learn how to solve simultaneous linear equation using matrix method. So we have this equation: a half x plus y is equal to 8 and 3 over 2x minus a third y is equal to 14. So we need to use matrix method, and I will show you step by step, and by the end of this lesson you'll be able to use matrix method to solve any kind of simultaneous linear equation. So let us begin. So the first thing we are going to do, since we have the first equation and also you have the second equation, and we have some fraction of it. So for the first equation, I'll remove the fraction by multiplying through by 2. So if I multiply through by 2, half of x I multiply by 2, I'll get x, then plus 2y multiplied by 2, I get 2y will be equal to 8 times 2, I get 16. The same thing I'll do for the second equation. I remove the fraction by multiplying through by the LCM of 2 and 3, and the LCM of 2 and 3 is 6, so multiply through by 6, so 3 over 2x times 6, I'll end up getting 9x, then minus a third y times 6, I will end up getting 2y will be equal to 14 times 6, I get 84. So these two equations now, that's what now I have the simplified simultaneous equation. The next step I'm going to take is now to rewrite the two simultaneous equations in a matrix form. And when I say in matrix form, the first thing we are going to do, we need to extract the coefficient matrix. Then I multiply by the variable matrix, which will be equal to constant matrix. So just to show you step by step, and it will be so clear for you. Now, to extract the coefficient matrix for these two simultaneous equations, so coefficient of x is 1, coefficient of y, it is 2, then coefficient of x, it is 9, and coefficient of y is minus 2. So I enclose them in brackets. So this is the coefficient matrix. Then you have the variable matrix, so that involves x and y. So we write them in column matrix x, y. Then will be equal to the constant matrix. So here we have 16 and 84. We enclose them in bracket. Now, the next step we need to take is, now we find the determinant of the coefficient matrix. To get the determinant of the coefficient matrix is the product of elements in the main diagonal, that is 1 and 2. 1 times minus 2, that is minus 2, minus product of element in the other diagonal or the secondary diagonal, that is 9 times 2, which is 18. So minus 2 minus 18, that is minus 20. Also I need to get the inverse of the matrix. That is the next step, inverse of coefficient matrix. So to get the inverse of the coefficient matrix is 1 over determinant. Then the other thing I need to do, I interchange the elements in the main diagonal. that is 1 and minus 2 interchange position, such that I'll have minus 2 and 1 there. Then in the secondary diagonal, I reverse the sign of the elements. So 2 will be minus 2 and 9 will be minus 9. So the next step will be pre-multiplying the matrix equation by the inverse. Pre-multiply on both sides. So if we pre-multiply on both sides, then we shall have, so the inverse is minus 1 over 20 bracket minus 2 minus 2 minus 9 1. Then I have 1 2. Now this what now I have, I rewrite it, so times 1 2 9 minus 2 multiplied by x y will be equal to minus 1 over 20. Also on the right hand side I pre-multiply by the inverse, so inverse is minus 1 over 20 minus 2 minus 2 minus 9 1, then multiply by the constant matrix, which is 1684. Therefore the next step, I just keep the minus 1 over 20 out. I'll just multiply it towards the end. So multiply these matrices. I believe you know the order of multiplying matrices. So I have first row, I multiply with the first column. So minus 2 times 1, that is minus 2. Then plus minus 2 times 9, so that will be minus 18. Then the other element is minus 2, then multiply first row times second column. So minus 2 times 2, that is minus 4. Then plus minus 2 times minus 2, so plus 4. The other element is minus 1 times 1, minus 9 times 1, that is minus 9, plus 1 times 9 plus 9. Then the other element will be minus 9 times 2, which is minus 18, then plus 1 times minus 2, which will be minus 2. Then I have xy, the variable matrix, will be equal to minus 1 over 20. Again, to get the elements, so minus 2 times 16, that is minus 32. Then plus minus 2 times 84, that will be minus 168. Then the other element will be obtained by multiplying minus 9 times 16, which is minus 144, and plus 1 times 84, so plus 84. Then we add this, so we have minus 1 over 20, then minus 2 times minus plus, minus 2 minus 18 minus 20, then minus 4 plus 4, 0, minus 9 plus 9, 0, and minus 18 minus 2 minus 20, close the bracket. Then I have x, y will be equal to minus 1 over 20. So to bracket minus 2 minus 32 minus 168, that is minus 200, and minus 144 plus 84, that is minus 60. Next step, now open the bracket and multiply by multiply by the scalar, so minus 1 over 20 times minus 20. So multiply this by each element, so we shall end up getting 1, then 0, 0, 1. Then multiply by xy, will be equal to, again do the same, minus 1 over 20 times minus 200, that is 10, and minus 1 over 20 times minus 60, that is 3. Now, this is an identity matrix which behaves like 1. Therefore, we shall have x, y will be equal to 10, 3. In other words, it means that x is equal to 10 and y is equal to 3. And that's how we solve it using matrix method. I hope that is so clear, and therefore I want you to try this one, which is use matrix 7t is equal to 1 and 5t minus 3s is equal to minus 3. I want you to use matrix method, solve it. Once you are able to do it, t will be equal to 1 over 7 and s will be equal to 26 over 21. Try to use the matrix method and solve it. So thank you so much. Remember to comment in the section below. Also subscribe to my channel for more videos. Thank you so much.